All right, so a few of the blanks already filled in here for section 9.4. Volume is cubic units, and it's the area of the base times the height. So on this rectangular prism, for example A, the area of my base. Now I could call the base the bottom side, the front side, the left side, the right side, the top side. Any of them qualify as a base, because to be a base on a prism, you have to have two sides that are on opposite ends and they are the exact same. Well, on rectangular prisms, that's true on every side. Every side's got a partner side that's the exact same. So let's just say I call this my base. And I use the formula V equals capital BH. Capital B would mean finding the area of that bottom base. What two units or what two lengths am I going to multiply together to find it? What is it? 6 times 8. And then the height would be how far it takes you, how far it is from the bottom base to the top base. Frank? Yes. Somebody else want to answer that question other than Lucas? Sierra? What is it? 15. All right. So we can multiply 6 times 8 times 15. Have your calculators ready. Somebody go ahead and do that and raise your hand when you have it. Hannah? Yards cubed. There you go. Nice job. That's it. It's not find the area of one side and double it, find the area of the other side and double it, and find the area of the other side and double it. It's just find the area of one side and times by the height. Now, you guys told me that you can multiply these numbers together in any order, and that's because on a rectangular prism, we also could have said that this side was the base. And that wouldn't have changed our answer. It could be a base. If that was my base, then I would multiply 8 times 15. And then the distance between that rectangle to the other rectangle, which is the height, now the height's been twisted, is 6. And that's still going to give us 720. So if you just want to multiply the numbers together in whatever order you want to, that's completely fine. So what about example B? Let's call the front side our base. Branson, what two numbers would I multiply to get the area of the front side base? Okay. So the area of my base, capital B, is 4 times 3. And then Branson, if the front side is my base, the height here is going to be the distance between those two bases, which is 5. So height does not mean always straight up and down. The height of a prism, depending on what side your base, could also be like a depth. For example, when you go to the movie theater and you pay for a 3D ticket to go see a movie, you're not paying for length and width. That's already provided. You're paying for the depth, right? That's that third dimension that wasn't there before. It looks like something's popping out at you. And so height or depth, the same thing, could be like this. So height does not always mean it's vertical straight up and down. Okay, when you look at a movie theater screen, you already have height. Okay, so you're paying for that depth. What is 4 times 3 times 5, Natalie? 60 what? 60 inches cubed. There we go. Finding volume, pretty easy to do, especially if I give you one of these shapes. It's a cube. Since all the side lengths on a cube are equal, the volume of a cube could just be s cubed, or s times s times s, side times side times side, because the length, width, and height are all the same. So if you saw me write for the volume of a cube 4 to the power of 3, you would know that that means 4 times 4 times 4. By the way, the reason we say something that's been raised to the third power is being cubed is because by raising a number to the third power, you are cubing it and finding the volume of a cube that has those side lengths. For the same reason, if I square 4 and get 16, you're telling me the area of a square. That's 4 by 4. What's 4 times 4 times 4? 64. Now, depending on what type of calculator you have, you might have a shortcut for doing that. You might have a button that looks like this, or a button that looks like this, or you might have one of these buttons like I do on my calculator, which I hit 4 and then hit that arrow and then put to the third power. You could, so depending on your calculators are different. Or you could do it old school and just do 4 times 4 times 4. But if you have a calculator and you're not sure how to cube a number, come see me after class and I can show you how to do it on your particular one, because everyone's kind of got a different one. You maybe borrow one of mine, or if you have one that looks like this or one that looks different. So I can find it for you if you want me to help you with that. Cubes are so easy, you don't even have to know what the shape looks like. They can just describe it for you and say it's got 1 centimeter sides. Well, that would mean that the length, the width, and the height, or the area of my base times the height, is 1 times 1 times 1. Parker, what's 1 times 1 times 1? 1. Yeah. You're like, how did that change my answer? Well, it's 1 cubic centimeter. Not 1 centimeter, 1 cubic centimeter. And there's a difference. There's a difference between 1 centimeter, a square centimeter, and a cubic centimeter. For the same reason, if you look at the tiles on the ground, these tiles are 1 foot by 1 foot tiles. 1 foot is the side length. 1 foot squared is what I'm standing on. 1 foot cubed would be raising it up this high off the ground. So they're different. Just saying 1 centimeter would be wrong. 1 cubic centimeter is very big compared to 1 centimeter. Even though the answer is still 1, the units are centimeters cubed instead of normal centimeters. Now, that formula of V equals capital BH can be used for any prism. It can be used for triangular prisms, like we'll talk about in a moment, obviously the rectangular prisms. Also for pentagonal, hexagonal, octagonal, decagonal, dodecagonal, undecagonal, nonagonal, heptagonal, all sorts of gonals. It works for any prism, regardless of what the base looks like. So, although you don't know the formula to find the area of an octagon, if I told you that capital B was 16 inches squared, because it's an area of the base, and I told you that the height was 3, what would you do with those two numbers? You just multiply them. Yeah. If you know what capital B is and you know what H is, volume is just capital B times H. So you'll have some homework questions in tonight's homework that look like that, but they're going to tell you what capital B is, and they're going to tell you how tall it is. And so you just multiply capital B times the height. They're actually the easiest ones on the whole homework because they already give you the numbers. You just have to multiply them. There are formulas to find hexagons and octagons and pentagons, find the area of those, but that's not for us. That's for high school. It's for geometry class. All right. Now, for a triangular prism, they are not going to tell you what capital B is. They're going to expect you to know the triangle formula, and we have used it an awful lot. The triangle formula is 1/2 little b little h. So when I say base of a triangle, that's not the same as saying the base of the prism. If I say the height of the triangle, that's not the same as saying the height of the prism. On a rectangular prism, I can use any of the rectangles to be my base. But on a triangular prism, I have to use the triangle as my base. So the bottom side is not my base. The area of that base is going to be, so V equals capital BH is my formula. Capital B is going to be 1/2, I'm getting that from up here, the top formula here, 1/2 times the base of the triangle, not the base on the prism, but the base of the triangle. The base and height of the triangle always meet at a right angle. Do you see the right angle? Okay. That means the base of that triangle is 5.5, and the height of that triangle is 2. So everything that I put in parentheses is my capital B. I'm missing the height of the prism. And you might be thinking, wait a second, you just said it was 2. The height of the triangle is 2. That's going to help me find my capital B. How far apart are those triangles? From this side to that side, how far apart are they? 4. So I have to multiply by 4, and that's going to be my H. So there's my capital B, and then we'll say right here is my H. I don't need to know how to find the area of the other rectangles. I just need to know how to find the area of that triangle, and then what's the distance between that and the other one. That's going to be my volume. Now, you'll notice a couple things here. First of all, you should notice something particularly different. There's no 2 in front of the parentheses. That's because I don't care how many sides I have. I'm not doing surface area. I just need to do the area of one of the bases. So the 2 can't cancel out with the 1/2. That's not going to happen here. But if there's an even number inside the parentheses, if my base or height are even, I could take half of that. And actually, the height of the triangle here was 2. So I could do half of this 2. What's half of 2? 1. So I can still apply the half, just have to do inside the parentheses. If half of 2 is 1, 5.5 times 1 is still 5.5. So I just need to do 5.5 times 4. Addison? 22. That's right. And what's my label? That's right. Could one of you two ladies shut the door for me? They're about ready to do some cart rides, I think. Yeah, some sort of science lab today. All right, let's look at example F, another triangular prism. This is a right triangle, so I'm going to find the area of my right triangle base side here. You see the right angle? Always look for the right angle when you're doing the area of your triangle. It's going to connect your base and height. In this case, they're on the outsides. V equals capital B times H. Here's my capital B. 1/2 times, what's the base of that triangle? 12 times, what's the height of that triangle? 5. There's my capital B. Don't times it by 2. We're not doing surface area, so don't times it by 2. How far away is that triangle base from its partner triangle base? 9. Yeah, the only other number we haven't used. So when I say the height of the prism is 9, don't mistakenly think that I'm telling you that the height of the triangle is 9, because the height of the triangle is 5. But if I were to tip it onto its base, the prism, the 2 triangles would be 9 meters apart. That's the height of the prism. The height of the prism is 9. The height of the triangle itself is just 5. So there's 2 different heights going on here. Is there an even number inside my parentheses? Yes. What is half of 12? 6. What is 6 times 5? 30. And what's 30 times 9? 270. Don't even need a calculator because 30 times 9 is the same as 3 times 9 with an extra 0. My label is meters cubed. Volume takes you a lot less time to do. Example G. Am I going too fast? Did you guys get that one written down? We good so far? Okay. Do you see the triangle base? Is it on the front like it was last time? It's on the bottom. Bases can be on bottom. They can be on the front. They can be wherever they need to be. But if it's a triangular prism, the triangle side, I know for sure is my base. And so there's my base. That base is going to have an area of 1/2 times what 2 numbers? 4 and 6. 4 is base of my triangle. 6 is the height of my triangle. What's the height of my prism? 5. Yes, so there's a difference between the height of the triangle and the height of the prism. Yes. What's half of 4? 2. Instead of doing 2 times 6, half of 4 is 2. What's 2 times 5? 10 times 6. You may not need a calculator for some of these problems. 60 millimeters cubed. Yes, everything is cubic units. Volume is cubic units. Find the area of your one base side. You have 2 of them, but I just need 1 times by the height. That's it. Unlike surface area, you don't need to use all the side lengths on a prism. You'll notice they only gave us 3 numbers here. This one, they gave us 1, 2, 3, 4, 5 numbers. We're not going to use them all. So I would need to use them all if I was doing surface area, but not volume. Here's my front side triangle. I said rectangle. Here's my front side triangle. To find the area of that triangle, 1/2 times the base. Ella, what's the base of that triangle? Awesome. Times the height of that triangle. Ella, what's the height? 4. I don't need that 5 whatsoever to help me find the area of that triangle. Just 1/2 times 6 times 4. I'm going to put that in parentheses because that's my capital B. My height, because I do capital BH, What is the distance between this triangle and the one on the back side, Addison?
7.
It's 7. Yeah, so a lot of people get confused here because when they say the height of the prism, they put 4. 4 is not the height of the prism. 4 is the height of the triangle. You've already used 4, so we have to use 7. That meant I didn't actually use this 5 either. Would have used them if I was doing the area of those rectangles, but I'm not doing. I don't care about the rectangles. I just care about my one base side times the height, or in this case, the depth. What's half of 6? 3 times 4? 12 times 7. 84? 84 meters cubed. Remember, surface area, I'd have to find areas and add them together. There's really no adding that I have to do when I'm finding volumes. So if, on my work paper for tonight's homework, if you just want to write down 1/2 times 6 times 4 times 7 and just put your answer, that's okay. Because it's all multiplication. You could do it all in your calculator in one step. Unlike surface area, which you have to do different steps because you're adding them together. So as long as your work paper has that work and that answer, I don't care if you do any simplifying or anything else. All right, here we have I. I is a parallelogram prism like the one on the back side of the worksheet we just went over. That means my base is this parallelogram right on the front. So my base is the front side. It's a parallelogram prism. You have to use the parallelogram as your base. Now, fortunately for us, the area of a parallelogram is the same as a rectangle. Do you see the right angle? Always connects the base and height. What's the base? What's the height? 2. The area of a parallelogram is base times height in the same way that a rectangle is base times height. The only difference is that on a rectangle, that right angle makes the two sides match up. In a parallelogram, the right angle should be inside the shape somewhere because the height's going to still have to go straight up and down. What is the distance between that front side parallelogram and the one on the back side? 4. So that's my height of the prism, and I don't use the 2.5 at all because I'm not doing surface area. What's 4 times 2? 8 times 4? 32 meters cubed. That might be the hardest part of tonight's homework, is try to go back to or using cubic units instead of going back to using square units. All right, example J is a trapezoidal prism. It has a trapezoid part on the front side on the top and the trapezoid side on the bottom. And so to find my volume, I still use the same formula. It's just my capital B is going to change. I like to think of capital B as a drop-down menu. Do you guys know, like when you put your birthday in on your iPhone or whatever, you have to like scroll to the right month, scroll to the right day in the year. So imagine capital B being one of those drop menus, the scroll menus, and you're just scrolling through all the formulas you know. Is it a rectangle base? No, so not length times width. Is it a triangle base? No, not 1/2 BH. Is it a parallelogram base? No. Is it a circle base? Is it pi r squared? No, that's tomorrow's homework. This is a trapezoid. Somewhere in that list of scrolling, rotating area formulas you have is this formula. 1/2 times B1 plus B2 times H. That's how you find the area of a trapezoid. And so the trapezoid we need to find the area of is the one right there on the top. So it's going to have, put this in parentheses, 1/2 times, add the bases together. Well, the bases are the two parallel sides of your parallelogram. That side right there and that side right there. The two parallel sides. So what's 12 and 6 add up to? 18. So B1 plus B2 is 18. And then the height of the trapezoid is how far it is from base 1 to base 2. 4. You're exactly right. That 4 right there. The height from base 1 to base 2. That's going to give you the area of your trapezoid, your capital B. Now I have to multiply that by the distance between this. This is the height. The height of a prism does not mean straight up and down height, although this one is. The height of a prism is how far is it from one base to the other base? It's 3. So if you look at all the numbers we did use, we never used that 5 or that 5. Just because they give them to you doesn't mean you'll actually use them. So what's half of 18? 9. 9 times 4. 36 times 3. 108. The volume is 108 what? Inches cubed. That's right, 108 inches cubed. So if you ever, and by the way, I got these 3 homework problems out of last week's homework, where you would have needed all those sides because you were doing surface area. You don't need them today. So if you have problems like this where they give you more numbers than you need, just locate the ones you do need. Find the area of your base times the height. We're going to stop right there for today. For those of you starting, and I hope it's all of you, starting your homework tonight, on the 9.4 homework, I have 2 homework questions, number 14 and number 22, that we're going to do tomorrow before we start our surface, our volume of cylinders. Sorry, no surface area, volume of cylinders homework. So you should be able to do all the other ones in your homework. Plus, we're going to do one more problem with movie theater popcorn, which always makes me hungry. And you can start 9.4. All right, on this example, it says a movie theater designs 2 bags that hold 96 cubic inches of popcorn. Part A, find the height of each bag. Find the height of each bag. So they give us some dimensions. Each bag is a little bit different. They give us the dimensions on these bags, except for the height of them, of course. How are we going to be able to find the height on these bags if they don't tell us what it originally is here, Hannah? Good. What is the volume? 96. Perfect. Okay. When you read that, it says 96 cubic inches. What do we label in cubic units? Volume. So this 96 is our volume. Nice job. So we're going to use the same formula we've been using, except instead of plugging in for capital B and H, we're going to plug in for capital V and capital B because we don't know the height. So Hannah, say it again. What am I plugging in for capital V? 96 for the volume. Excellent. Okay. Now the area of the base has a length and width of 3 and 4. Maddox, what's that make the area of the base? 12, exactly. So for capital B, we're going to plug in 12, and then we don't know the height. So we leave that as H. How do I solve an equation like that? Divide. Doesn't it make sense? How many times have we worked backwards this year and had to divide when we work backwards? Doesn't that seem to be a trend that we're always doing? Okay. So Branson, what do you get when you divide 96 by 12? 8. So the height of this bag is 8 inches. And the reason I'm not labeling in cubic inches, as Hannah said, we already know the volume. 8 inches is how tall the bag is, just like the length and width were labeled in inches, we're going to label its height in inches. So now you can scratch out this H here and replace it with an 8 inches. We now know how tall that bag is. Have you guys been doing anything similar in science class where you've used a formula like this? Maybe something, a quiz you have coming up this week? Force equals what? Mass times acceleration. Isn't that the same kind of thing where instead of V equals VH, it's F equals MA? If you have M and A, you multiply them, but if you have F and one of the other ones, what do you have to do? Divide it over, just like we did for this one. Exactly right. So it's very similar to what you guys are doing currently in science. Now for the second bag, it's a little shorter, a little bit wider, has the same volume. Both bags hold 96 cubic inches of popcorn. So we're still going to plug in 96 for our capital V. Our base is 4 by 4. Alexis, what is a 4 by 4 square going to have as its area? 16. So we're going to plug in 16 for capital B, and we're going to divide it over just like we did before. Alexis, go ahead and divide 96 by 16. 6. That's right. So our height of this bag is going to be 6 inches. Go ahead and scratch out that H and replace it with 6 inches. Now, if you're purchasing popcorn from this movie theater, do you have a preference on which bag? Go ahead, explain why. Wait a second. They both hold the same amount. So why would they give you a cheaper price if they're both the same amount? Okay, so we'll get to that in a second. You're talking about how much, maybe how much paper they're using. Okay, that's the second part. But let me ask you as the consumer, if I told you both bags hold the same amount of popcorn, are you going to throw a fit with which one I give you? Probably not. Now, there's certain things that you might have a preference over. I didn't know if this is where you were going, Lucas. If you give me a tall and skinny bag and I have to reach in there to get the popcorn, now I'm going to get butter all the way up to my elbow, right? Well, I don't want that. I would prefer the one that's got a wider opening, right? A little bit shorter. I have my preferences, but if you told me that each hold the same amount of popcorn, I'm not going to throw a fit if I know that each bag is equal in volume. But it might actually be cheaper, as Lucas was alluding to, for one to make one over the other. Because even though they hold the same amount of popcorn, they don't have the same amount of paper to make the bags. The amount of paper is different. How is this problem going to switch from part A to part B when I'm talking about cheaper in terms of paper? If I wanted to know how much paper it's using, what kind of problem would that be? Surface area, exactly. Yeah, volume's the space inside, but the paper is around the edges. That would be surface area. So what we're going to do now for part B is we're going to find the surface area of each of these bags to see which one uses the most paper. Because if it's all the same to the customers, but it can be cheaper to produce, the company is going to want to save money any way they can, right? So how many sides do rectangular prisms normally have? 6. What about these? Why? Okay. I'm going to ask you to raise your hand from now on. You're providing good feedback, but raise your hand so everyone else has a chance to say something as well. Okay. There are 5, and explain why you said 5 again, Lucas, for anyone that couldn't hear. The top's not there. Exactly. So why don't we start by finding the area of our bottom side, which we already said was 12. 3 times 4 is 12. Now we have the front side and the back side. Now we do have 2 of those. So how do we do that? How do we find the area of the front and back, Michael? Okay, 8's going to be part of it. 8 is the length of the blue rectangle. What is the width of the rectangle? 4. Yeah, so if we do 8 times 4, that's going to give us the front side. But the back side is the exact same. So Michael, what would you do once you find the area of the front side? Okay, how do you do that? Start over. Okay. Do it. You're suggesting you should do it again. Yeah. So what is 8 times 4? Okay, you're jumping all the way around. You're right. I am going to get 64 eventually. What I'm trying to get you to say is you're going to double it. Right? And you've already done that. You get 32, right? 8 times 4 is 32, but we're going to double that so that we wouldn't have to type in 8 times 4 again. We could just do 8 times 4 times 2. Now, you're probably thinking, wait a second, having nightmares of surface area from last week. Right? We said surface area takes more time to do, right? You're seeing this right now. We'd be done with 4 volume questions by now. Now we have the left and the right side. Addison, what are the dimensions of the left and right side? Okay, and there's also 2 of those. So go ahead and tell me what 2 3x8 sides would give you. 48, excellent. And then we'll add those together and I'll save us some time and do it real quick here. The 12, make sure I didn't lose battery, plus 64 plus 48 is going to give you 124 inches squared, because this is surface area, right? Not volume. So not cubic units, but square units. Now for bag B, I have a similar approach. you would find the area of its base, which is 4 times 4, which we already said was 16. There's only one of those bases because the top side's not there. What do you notice about bag B that's just a little different from bag A? Hannah? Oh, sorry, I thought your hand was up. Frank? It's shorter. Something else that might help us with the surface area, though. Natalie? Okay, so it's wider. Okay, still looking for how that would save me time. I'm looking to save time on this problem. Branson? The width is the same. So yes, it is shorter and it's actually a square, isn't it? Because it's a square base, you're not going to have just one 4x8, or sorry, now we're 6. One 4x6 side in the front and one in the back, but you've actually got a 4x6 side on the left and right. So how many 4x6 sides are there? 4 of them. Yeah, it's going to save us a little bit of time, right? So we have 4 4x6 sides. 4 times 6 times 4. Thomas, what do you get for that? 4 times 6, and then 4 of those. 96. Add that with the bottom side. You'll have all 5 sides on this popcorn bag. 96 plus 16 will give us 112. And also that's going to be in square inches. So which bag would be cheaper for the theater to produce? Why so? Not as much paper. That's right. And if you can have a bag that's not as much paper but holds the same amount of popcorn, that would save you some money and you wouldn't have to change anything and the customers wouldn't get too upset about that. In fact, I think most customers would probably prefer that bag. I know I would. All right, so a couple homework questions that I wanted to go over with you guys before we start today's lesson. And I wanted to go over number 14 because I've already had some students come up to me and say, I didn't need any help with this because it was just fill in the blank. Was that going to help you on your quiz Thursday? No, that's not. So we need to make sure we know how to do this. So you're going to write down your work and then you can put that on your work paper. And as I'm grading your work paper, I'm going to know who obviously showed their work for this problem and who did not show their work for this problem. So for number 14, it says, each locker is shaped like a rectangular prism. Now this should look familiar to you, right? A school locker, you guys use that every day. And for those of you that in gym class, maybe your lockers aren't that big, but I know in the South Gym locker room, those locker rooms are, or those lockers look similar to that, except in the South Gym, they're only cut in half, a little bit smaller space, but they look, the red color is kind of the gym. For whatever reason, that seems to be the color of a gym locker. So I in my high school, we had red as well, even though our school colors were blue. It's kind of weird. So for the school locker, I have a length of, or a width on the bottom there is 12 and 10, and then a height of 60. How do I find the volume then of the school locker? Raise your hand. Yes, Branson. 10 and 12 and 60, length and width and height, right? It's a rectangular prism. Okay, so Branson, go ahead and do that. And then I'm gonna have Lainey tell us the volume of the gym locker. And Lainey, what are you gonna multiply to find the volume of the gym locker? 48. And what else? You need to multiply length, width, and height. So you give me the height of 48. You gave me the length of 15. Which one are you missing? Oh, 12. The 12. There you go. All right. Go ahead and multiply those out. Branson, what did you get for the school locker? Oh, nice. Thanks for labeling it inches cubed because it's volume again. Yeah, we're talking about the space inside, right? So that would be volume. What did you get? How would you say it? There you go, 8,640. And what's it labeled going to be? Not squared, volume is inches cubed. There you go. All right. So even though the gym locker is considerably shorter than the school locker, the width increasing from 10 to 5 here is actually going to have a pretty big impact. And the gym locker actually has the larger volume. So now you know what number goes there. Now you know what number goes here for the volume of the gym locker. And then we said the gym locker is going to have more. And we have evidence to support our claim instead of just guessing on a drop-down box. Yes. Can be, yeah. It certainly helps for us if we're talking about prisms, if they're rectangular, right? They may not all be the same shape, but this one is. So we'll just go off of it. This is number 22 in last night's homework. It says the gas tank is 20% full at $3 per gallon. That's like so last week, right? At $3 per gallon of gas, find the cost to fill the tank if 1 gallon is 231 cubic inches. There's a lot going on in this problem. It's already 20% full. Gas costs $3 per gallon. I need to know how much it would cost to fill this tank. If I'm talking about the space inside of the tank, what am I referring to? Its volume. I should probably start with that. Now, I noticed a couple things. I don't know if you did. When you're looking at the length, width, and height there, what do you notice? Branson? There's some decimals. Okay. That doesn't scare me. Doesn't scare me. I have a calculator. What else? It's a rectangle. Yes. What about the dimensions of the rectangular prism? Natalie? Yes, it goes inches and feet. We can't have that. We're going to have to convert everything into the same units. Now, because my conversion up here says cubic inches, it would be easier for me to leave it in inch form versus changing it to feet. Does anyone know, I'm sure you all probably do, how many inches are in a foot? 12. So I need Andrea to multiply 1.25 by 12, so we know how many inches that is. And I need Caden to do the same thing with the 1.75. So we can convert those feet units into inches units. When you got it, go ahead, Andrea. All right, so she says that the width is going to be 15 inches, 1.25 times 12. Caden, what'd you get for the length there? 21 inches. All right, so now we know how many inches long the tank is, we know how many inches wide the tank is, and the height was already in inches. So to find its volume, just like I did for school lockers, I'm going to do length times width times height. And Hunter, what do you get for the volume of the entire gas tank? 3,465 inches cubed. Perfect. Okay. Now, the gas tank already has some gas in it. So when I'm going to fill this up, I want to know the cost to fill it up. Well, I'm not going to fill it all the way up. If 20% of the tank is full, what percent is still empty? 80%, right? Sorry, I couldn't see you back there. Maybe if you were sitting in your normal seat, not having to charge your iPad, I would see you more. So this is kind of like a discount problem, right? Instead of being 100% full, you've already got 20% in there. So you subtract, you only have to do the 80%, right? So we kind of did with discounts. So what I need to do is to find 80% of its volume, or 0.8 of its volume. Hunter, multiply your answer by 0.8. $2,772 cubic inches. That's what we need now. That's so much easier than trying to guess. Like a couple of years ago, I had a student come up to me. They were trying this problem on their own, and they drew this and said, I need to find the volume of that rectangular prism, which is the space of the air. I'm like, well, how would you do that if you don't know how much gas, like how much gas is in there, like how many inches tall the gas is? And they said they don't know. And I said, yeah, well, there's probably an easier way. The easier way is to figure out what the total tank is and then subtract out what we already have, which is the same thing as what we just did when we times by 0.8. We just subtracted 20% out. We just subtracted it right out. So that's how much gas I actually need. Now let's do a conversion. If each gallon of gas is 231 cubic inches, and I need 2,772 cubic inches, I need to know how many 231s it would take to get me to 2,772. Because every time 231 goes in, that's a gallon. So what do I do now? Addison? It's exactly what I do. Can you divide that by 200 and, what did I say, 31? Yeah. And, what a nice number. So we need 12 gallons of gas. Are we finished? We are not. The answer to the question did not say how many gallons of gas do you need. It said, how much is it going to cost? Well, if every gallon of gas is $3, Lucas, what would we do? And what would that give us? It would give us $36, our final answer. That was a lot of steps. That was converting feet to inches, step 1. Step 2, finding the volume. Step 3, finding 80% of the volume. Step 4, finding how many gallons that is. And then step 5, the cost of those gallons, ultimately leading us to paying $36 to fill that gas tank. I don't think you're going to fill your gas tank for $36 now, considering the price of the gas continues to rise around 20 cents every 2 days. It just keeps going up and up and up. And that's all related to the war in Ukraine right now, because the sanctions we put on Russia, we're not importing any of their gas. And so that's going to cost ours to go up. So hopefully we can not have it skyrocket here, but that's just what we're paying right now.